Now, if your system has just one database server, and for some reason if it goes down, your entire system will be unavailable until the server is brought back up. Or worse yet, what if something catastrophic happened to your server hardware? You will lose all the data. And you just can't afford to lose the data. For any company, data is extremely important, and losing it is a big no. So to avoid data loss or downtime, you can spin up another database server and copy the entire data from original server to this new server. Basically, you create a replica of your existing server. And you can put this server on standby so that if the original server fails, this replica can take over. Now, because the original server will be handling the requests, all the write operations will update the original database and not the replica, which means that replica will no longer be a replica. It will contain the stale data. And in case of failure, we can't let a server with stale data take over the original database. So we would need to update the replica as well. Now, there are two ways to update the replica. We can update it either synchronously or asynchronously. Synchronous means as soon as the write operation is performed on the original server, immediately it will be updated to the replica. And the write operation will be deemed successful only when the replica is updated. Asynchronous, on the other hand, means the replica won't be updated immediately. It will be updated at regular intervals, maybe like every 15 minutes or so. Now, it is good if you update the replica synchronously because a standby server should always be ready to take over with fresh data in case original database fails. And even if something exceptional happens to the original server, you won't lose any data. But this comes with a cost. Every write operation will be executed twice, which will impact the performance. On the other hand, if you update replicas asynchronously, your write operations will be much faster, but the replica will have stale data. And if something exceptional happens to your original server, you will lose all the data that was written to the original server since the last update. But replication is not just used to avoid data loss or downtime. It can be used to improve your system's performance by reducing the latency and increasing the throughput. So what you can do is you can make this replica an active server which will take the requests from the clients and respond. So instead of having one server, now you will have two servers attending the requests. And now, because there are two servers attending the requests, collectively they can handle more requests, which means increased throughput, and also load on one server will reduce, which means reduced latency. So basically it will improve the performance of the system. So okay, if there is a read request, you can read from any one of them. But what about the write operations? Write operation means either you want to add some data, or you want to delete some data, or you want to update some data. Now, if you perform a write operation on just one server, and in the future a read request on the same data went to the another server, it will return stale data. To avoid this, you would need to update other servers as well. Now again, it is good if you update the other database server synchronously, because both will have the same data at any point in time. So every read request will return the most recent data, no matter which server it is coming from. This is what we call data consistency. But again, it comes with a cost. Every write operation will be executed on all the servers. Okay? Which means latency will be impacted. On the other hand, if you update other servers asynchronously, Your write operations will be much faster, but the data won't be consistent. Okay? So it's a choice that you have to make as a system designer. For example, if you're building a flight booking system, you must update the database servers synchronously. Otherwise, what might happen is, let's say two users, Alice and Bob, who are in separate geographical locations, want to book the last flight ticket. Now, because they are in different geographical locations, their requests would probably be directed to different servers. And as you can imagine, if we update our servers asynchronously, our system would allow both of them to book the last ticket. Okay, so we would need to keep our data consistent by updating the database synchronously. But if you're building, let's say, a social networking platform, it's okay if the comments on a photo are updated after a few minutes. So for an application like social networking platform, you can update the servers asynchronously. Okay? So this is how we use replication to improve performance, avoid data loss and downtime. Okay?